Hello, I'm Leo Wang, and today we're exploring a fundamental shift in how we interact with technology. For decades, the world ran on what we can call Software 1.0, the traditional code manually written by programmers. Then came Software 2.0, the era of neural networks, where instead of writing explicit instructions, we curated datasets to train models to perform specific tasks like image recognition. But now we've entered a new transformative era, Software 3.0. Software 3.0 is powered by large language models, or LLMs. This represents a new kind of computer, one that is programmed not with complex code, but with natural language. Your prompts, written in plain English, are the new programs. This shift is as significant as any we've seen in the last 70 years of computing. My analysis suggests the most powerful analogy for understanding LLMs is to think of them as a new kind of operating system. The major AI labs are spending massive capital to build these foundational models. Much like building out a national power grid, they then provide access to this intelligence through APIs, metered like a utility. When these top-tier models experience downtime, it's like an intelligence brownout for the planet, as our reliance on them grows daily. But this analogy isn't perfect. These aren't simple commodities like electricity. They are incredibly complex software ecosystems, which makes them more akin to operating systems like Windows, macOS, or Linux. We're seeing a similar landscape emerge, a few powerful closed-source providers, and a growing open-source alternative. We are essentially in the 1960s of this new computing era. The computers, the LLMs, are massive, expensive, and centralized in the cloud. We access them as thin clients, using a form of time-sharing where our requests are batched together for efficiency. The personal computing revolution for AI, where powerful models run locally on our own devices, hasn't happened yet. To program this new OS, we must first understand its unique psychology. LLMs possess superhuman, encyclopedic knowledge, capable of recalling vast amounts of information. However, they also have significant cognitive deficits. They hallucinate, confidently inventing facts. They suffer from a form of digital amnesia. Their context window is like a short-term working memory that gets wiped clean, preventing them from learning and growing from interactions over time. They are also incredibly gullible and susceptible to security risks like prompt injection. We must design around these flaws to harness their power. So what are the biggest opportunities? The future isn't just about chatting with an AI. It's about building partial autonomy apps. Think of advanced AI-powered code editors. These tools don't just let you talk to an AI, they integrate it directly into the coding workflow. They manage the context of your entire project, orchestrate multiple AI calls behind the scenes, and most importantly, provide a graphical user interface. A visual diff showing code changes in red and green is far more efficient for a human to approve or reject than reading a block of text. This human-in-the-loop verification is critical. These apps feature what I call an autonomy slider. The user decides the level of AI intervention, from simple code completion to rewriting an entire file. The key to productivity is keeping the AI on a leash. An AI agent that generates 1,000 lines of code instantly is useless if it takes a human hours to verify it for bugs and correctness. The goal is a rapid, iterative loop of AI generation and human verification. This journey mirrors the development of self-driving cars. Early demos from over a decade ago showed seemingly perfect autonomous drives, suggesting the technology was imminent. Yet, here we are, still perfecting it. Software is tricky. Full, reliable autonomy is a long road. The immediate future of AI lies in creating powerful, cooperative tools where humans remain in control, using AI to augment their capabilities, not replace their judgment.